Impulse. What is impulse? Do you know what is the impulse? What is the impulse? I'll give an example. I give you a nail here. This nail, the idea is to hammer this nail on the floor. Okay? Here is the hammer. Here is the hammer. The idea is to hammer this nail onto the floor. Can you beat this nail into the floor by just beating it slowly? Can you do that? Will you have to beat very hard and fast, or you can do it by just beating slowly and the nail will go in? Can you do that?
No, sir. Hard and fast.
Hard and fast. More fast you do, what will happen? More easily, more fast it will get into the board. Right or not?
Yes, sir.
So a large force, so impulse is what? Impulse is a large force. Impulse is a very large force acting for a short time. Okay, short time. So impulse is a very large force that is acting for a short interval of time. Short time or interval of time. So in short, mathematically we can say impulse is the product of force into time. Impulse is a product of force into time. What do you think SI unit would be? Dimension will be? Dimension will be what?
Newton seconds.
It would be Newton. No, I'm talking about dimension. M L t to the power minus 2, then again t. So that gives me M L t to the power minus 1. This is dimension of impulse. And then, what do you think is SI unit? SI unit will be? So SI unit would be Newton second. Newton second. Okay? And MK system, we also need to know the MK in MK system. Newton force is kg meter per second square, but here it would be kg meter per second. Remember this, kg meter per second. So a question can be asked, kg meter per second is a unit of which physical quantity? Okay, so you can easily say that is impulse. Some examples of impulse if I give you. We all play cricket, right?
Yes.
What do you think? Is it if someone hits 6, right? Can he hit 6 with the cricket bat, which is very light? Okay,
No, sir.
and
No,
which is very light. And secondly, is that he hit the ball from a let's say from a very low speed ball. So we say a very low spin. Hitting 6 from a spin, is it easy or difficult?
Sir, it is difficult.
You play cricket, tell me, is it easy to hit 6 for a fast pace ball, or is it easy to hit 6 in the spin ball? Which one?
So with respect to speed, it is easier with the fast ball.
Yes. Why? Why?
Because for a slow speed ball, we need more force.
That you don't say that way now. Not only from force. Now Sachin used to hit. Sachin. Let me give an example. Weight of Sachin Tendulkar's
Yes, sir, his bat was very heavy.
bat. Okay? How much? 1.51 kg. Right? Weight of Dhoni's bat? Around how much? 1.3 kg. Right? So average weight. See how Sachin was such a huge average weight of bat. Okay? How much? 1.2 to 1.4 kg. Look, he figured out this trick, although he did not know the physics behind it. Right? Is it or not? Okay, no, this is cricket bat. Yeah, cricket bat. Yeah, cricket bat. I think they are not saying, yeah, cricket bat. Bats typically weigh from 2 to 7 ounce or 1.4 kg. So do you notice what how Sachin was such a great hit? No doubt. If he has mastered this skill, where did he master the skill of hitting the six? Two, if you look at the curve, if I draw this curve, look at here. So graph is I equal to force into t. So if I plot a graph between force versus time, how do you think the graph will be? Force versus time, how do you think the graph will be? Force versus time. The area under the curve should give you the area, and if the force is constant, I will come to that very soon. If the area is constant, if the force is constant, definitely it would be some kind of like this or like this or so whatever. But if it is not constant, if the force is variable, means the force is changing, you can see force and time, they are inversely proportional. Force and time is inversely proportional. Okay, if the force is variable, then the force can be like these and so on. So now the idea is you have to apply a very large force to a very small interval of time. Now if a cricketer has to hit the six, right, what will you need? He needs a large change in momentum, and if you will see very soon. Okay, I will come to examples later. Let me teach you a few more things, then I'll come to examples. I'll keep this thing because all this thing is necessary before let me teach all these things, then I'll come to examples, not before that. So now you see, impulse is force into time, right? So what can you write force? Force is nothing but mass into change, delta mv, m delta v by delta t.
Yes, sir.
Into delta t, can I write? Okay?
Yes, sir.
Cancel. So impulse is nothing but what? Change in momentum. It's a game of changing momentum. How fast you do the changing momentum is good. Right? It's a game of momentum, not over time. Right or not? I is equal to delta p. That's it. Is impulse a vector or scalar? Whose mic is this? Please adjust it properly. Okay? So what do you think? Impulse is equals to change in momentum. We'll do some problem in this, don't worry. Now, so graph. Okay, may I clean it?
Yes, sir.
Okay. Graph of I versus graph of F versus T. For an uniform force or constant force, F versus T, the graph, the area under the curve, the area under the FT curve gives, can you guess what?
So
Impulse. So an example, look at this. A uniform force was applied up to 2 seconds. Okay? Then again force has been, another high end force has been applied. Let's say this is 2 Newton. Okay? And then I say that little bit increase is there, and then again it's a constant. Understand?
yes, sir.
So what is the impulse between 0 to 2 seconds? How will you find? Just the area under the area of the shaded regions.
Yes.
So impulse would be, area of the shaded region would be how much? 2 into 2. That is 4. What is the unit? What is the Newton second?
Newton.
That is the one. When force is uniform and not varying. May I clean it?
Yes, sir.
May I clean it?
Yes, sir.
Another graph can also be possible. Now we will do some numerical on this, you will see. Now when force is variable, now when the force is variable, it can be anything. Then impulse has to be written like this. I is equals to, you have to consider the force to be constant for a very small interval of time. Then it has to be T1 to T2 F dt. Okay? Because at that time the force you can explain like this way. Force can be explained as di by dt. What is I? I being the impulse and t being the time interval, which you can be written as di is equals to f dt, or total impulse or full impulse would be, then I will be integral of t1 to t2 f dt. Okay? Understand? So again it is the area under which curve? Ft curve.
Yes.
So how does the curve look then? Now curve can be anything now. Based on the f can be an equation. For example, now look, f can be this. F dt is like this. What is the equation I give you at that time? X plus 2, no? Okay, let me make one. X plus 2 whole square, x minus 1, right? And again x minus 2, so on. Okay? So here t, so these are all t, sorry, it would be all t because df by dt will find out. Anyway, so it can be an equation. X is here my t. Okay? So in that way also it can be done. Got it? So then the curve can be anything at that time. For example, the curve can be maybe something like this, the bell-shaped curve. So area under this curve, this is done with integration. Area under the curve we can easily do. This is a, this is, let's say this is 0, this is a. So you can easily find using integration, which you'll learn in class 12, how this is done. Okay? So this is force, this is time. Understand? Let us take an example. Then we can proceed. Now let me give you an examples of impulse. Examples of impulse. What are different examples of impulse? So first thing, number 1. So you can notice here one thing. I is ft, means keeping the impulse to be constant, I can write I by t is equals to f. So if a very large force is coming, if you want to, and you can write this as what? Rate of change of momentum, dp by dt. Right? You can write this as m delta v by t. Right? So if you want to reduce the momentum, don't cut this t. If you want to reduce this momentum, what should you do? The time interval should be more, right?
Yes, sir.
So
Yes.
when a cricketer wants to catch a ball without hitting his hand, what he does? He what?
So pulls back.
Increases the time
Pulls
interval.
back the time.
Can I just write delta t? Increase the time interval
Yes, sir.
by gradually collecting the ball. No?
Yes, sir.
Gradually collecting the catch, I will say. If you hold it like this way, look at the picture. If you hold it like this, will you be able to catch the ball?
Sir, it will bounce if it is
Yeah.
already high.
Then that is conservation of that is collision. So you have to hold it like this, slowly and gradually. Am I right or not?
Yes.
Yes.
Then that was the first thing. Second application. Now the opposite thing. So if you want a large force, in order to hit a 6, okay, a large force can be imparted to a what? High speed ball by reducing what?
Time.
Reducing the time interval. No? Try to send it to 6 by just hitting it slowly. When you are defensing it, does it go to 6 at that time? You are again using that 1.5 kg only. Is it or not?
Yes.
So in fact, Sachin's hit to 6 to go across the boundary, I'll tell you, his contribution no doubt is there. But don't neglect the contribution of the bowler. If the bowler do not give a very high speed ball, physics do not allow you to hit 6. Okay, so it's a game of skill of physics, right? If you understand the physics, you can be a great cricketer in the first day only. Okay, I will take away 1.5 kg cricket bat from Sachin or the person or the great cricketer maybe. It will not be so easy to hit 6s and 4. Believe me. Understand?
Yes.
Yes, sir.
Then next is, if you see trains, I'm giving an example of train is, I'll show you. Look at this. What is this? We're interested in this one. Do you see these shockers?
Yes, sir.
What is the purpose of this? What is the purpose of these things?
So, to absorb the shock.
Yes,
expand
to
it.
reduce what? So in this case, what to reduce? See the time interval.
It's a time mirror.
So time interval, it reduces this what? Again that catching activity, no? Again that catching activity, na? Same thing, just like the hand of the cricketer who just absorbed the ball, no? So buffers are provided. Buffers or shock absorbers, right? Shock absorbers are provided. Shock absorbers are provided both in car and in train, bogies, to what? To reduce the jerk. To reduce the jerk, which is, jerk is nothing but the impact force, no, but the impulse, right? By reducing what? By increasing the time interval to collect F, na?
Yes.
This is the one. Similarly, there are another thing that is called that will do. This will do. So similarly, you can find out many other example. Okay, another one, the most important one. Glass utensils are kept in what? How are they kept? Are kept in papers, no, cardboard. These days you can see specially designed
Yes, sir. Yes, sir.
Yes, sir. This thermal.
yes, specially designed packing boxes.
Yes.
So these are all example of impulses. May I clean it?
Yes.
So wait a minute, the last point.
So if you are falling from a
Yes,
tree, so one question of question of impulses. Oh, another example. Falling from a height to a sand surface is less paining, no,
Yes,
than falling on a concrete. You describe this.
sir. Yes.
Than falling on a concrete floor. Do you agree or not?
Yes, sir. So it increases the time to come to rest.
Time interval, as a result, that huge impact force, no, that huge impulse force,
Yes.
impulse will get reduced, no?
Yes, sir.
So, may I clean it?
Yes, sir.
Let us take an example. Let us take a question. If I give you, let us do this question. Let me make a question on that cricket thing. Let's say you are playing a cricket. Okay? Okay, find the impulse. Find the impulse produced by a cricketer bat when he hits a ball of, how much do you think the weight of a ball? Deuce ball? 150 gram to 200 gram? Ball of 200 gram. 200 gram.
Yes, sir.
200 gram. When you see 200 gram, when the bowler bowled at the cricketer, I'm using the word cricketer, you can use the batsman, at the batsman with speed, how much? Tell me. Give me a data of this one.
So 140 kilometers per hour.
Okay, 140 kilometer per hour. Very good. Okay. Got it? Wait. I'll include, this is the first question. Find the impulse, right? Second part of the question. If the ball, okay, look at this. 140 kilometer per hour. Understand?
Yes.
If the ball follow along a direction of 30 degree to the horizontal. Okay, clear?
Yes, sir.
How far does the ball go? Okay, if the stadium size is, stadium width, I will say, stadium width is, how much do you think the stadium width? Let us say in the width of
So including both the sides.
I'll just take the rough width of what is that? Eden Garden Stadium. What is the dimension of Eden Garden Stadium? You see, it is a curve length, so 130, radial width of 35. I will take this as 35 meter. Okay, if the stadium width is 35 meter, comment, is it a sixer or a what? 4. Can you do?
Yes.
Can you do?
Yes.
Abhi?
So I will try.
So first thing I'm giving you the hint. I'm waiting for 5 minutes. You try it. So you can imagine the picture. No, this is the bat.
Yes.
He hit the ball here. The ball I'm taking, it's a perfectly elastic collision. We'll see that elastic collision, what is it. So whatever velocity is been imparted there, the same one is sent out. Okay? So it is going at how much angle? 30 degree.
30 degrees.
So you can easily find the impulse. That is a very easy question to find. So what will be the force? For impulse is nothing but change in momentum. That's it. I taught you just few minutes back. So mass is how much?
So 0.2 kg.
Yes. 0.2 kg.
Yes, sir.
So change in final minus initial velocity is how much? Both the cases you have to be careful here. So mass is 0.2 kg.
Yes, sir.
0.2. We will deal with this kind of problem. You will be able to solve more accurately in another chapter. So 0.2 into how much is the velocity? 140 km per hour is actually how much? Tell me. Into 5 by 18. How much?
Yes, sir.
5 by 18. Yeah, it is almost equal to 20. So 18, 20.
Yes, sir.
How much? Half is 7. 5 7 is 35. Little less than 35. Maybe 34 or 33. 33 or 34 like that. No? How much is it?
So 38 point something I'm getting.
38. 38, no?
Yes, sir.
38. Yeah, it should be 38. More. 38 kilometer. 38 meter per second. Speed is 38 meter per second. Okay?
Yes, sir.
38 minus. So this is 38. Now you see how to take it. Final is, you see, the ball is coming this way at 38 meter per second. This is initial velocity. After getting hit, it is going this side.
Yes.
Okay, which is again, now here we are considering, we are checking that the ball and thing both are at same way. Okay, so you take this as minus 38 only. Got it? So
Yes.
final is opposite, so minus 38. So how much is? Solve it and tell me how much.
So minus 7.6 Newton seconds.
Minus
7.6 Newton seconds.
say once again, minus
7.6 Newton seconds.
Newton second. Okay, so in every 1 second you are applying how much force?
So minus 7.6 Newtons. 7.6 Newtons.
7.6 Newton. Okay, minus 7.6 Newton. Is impulse vector or scalar?
So vector.
Very good.
So,
Very good. So negative sign implies what? Negative sign implies
So it's in opposite direction.
means direction is
Opposite.
from where to where? From batsman to bowler.
so
Now don't stop here. What do you have to carry on? So we have got the impulse. I have given you the 30 degree angle, right? I have given you the width. Check it. Check. So what is the velocity? You see final velocity is also 38. So what is the horizontal range? Horizontal range will be how much? U square. How was it?
sin 2 theta by g.
Yeah, U square sine
So
2
you put
sine
theta by g.
sine
2
theta
theta by g.
sine 2 theta by, yeah, sine 2 theta by g. Solve it. See, is it going or how much is it coming? And then comment your answer.
So the horizontal range is coming 127.6 meters.
100.
127.6 meters.
Okay, so if we take Eden Garden, if we take this side also 130, oh my god. No, that side would be the 6, na? Is it or not?
Yes, sir.
Top view, you see, you
Sir,
see.
can Abhishek repeat his answer?
Huh?
Sir, can Abhishek repeat his answer?
How much you got? You got, tell me how much, tell me.
Sir, I got 1249.06 meters.
124?
Something. Well, no, sir. 120. Yes, sir. 124.906 meters.
126.90, no? Maybe.
So 124.
124. You're getting 124. That is 125 meter, right?
Yes, sir.
What about you? Abhi?
So maybe I took GS 10 and
Okay,
and
okay.
root 3 as 1.7.
Yeah, I think he has also taken as.
So I took G as 9.8.
Oh, then it would be different only.
Yes, sir.
So 130. Is it a
This one would
6?
be-
Is it a 6?
So it would be 4.
It will be 4. It will be considered 4, right?
Yes.
Yes, sir.
It will be considered 4. Because the longer side will be the 6 only, na?
Yes.
Because we are taking the same direction only. Now if this is this side being the 135 meter, and this dimension would be how much? This is 35 meter, right?
Yes.
With 35.
So, but it should be a 6 because the batsman would be hitting from the center.
So you'll be doing from here.
Yes, sir.
If he does here, from here it should be 6. But if he goes
Yes,
this
sir.
way, then it is not a 6.
Yes, sir.
So whatever that, I'm leaving that. You can see from here which way the pitch is. The pitch is in which way, I leave that for you to decide. You can see, if I look at the picture, you can see, now this is Eden Garden, rough Eden Garden. Or you can, this is the one. This is the one, you can see the oval side. Yeah, it's a 6.
Yes, sir.
It is a 6. No,
Yes, sir.
it is a 6. So you write your answer, it would be 6. May I clear it?
Yes,
Now
sir.
another question. Now you write a machine gun can fire a bullet of mass. Let us see how much is the mass of a bullet. Approximate mass of a bullet, 50 gram. Mass of 50 gram. Okay. Speed of bullet, which is one? Speed of AK-47 bullet. Speed of AK-47 bullet. Okay.
Yes.
700 meters per second. Okay, take this data. 705 meters per second, built around a 7% millimeter round muzzle and a velocity of 7 meters per second. It is a cycling firing rate of 600 rounds per minute. 600, we'll see to this. Okay, we'll come to that. So, yeah, I need to find, this will do. This is our data, we'll do. A machine gun can fire a bullet of mass of 500 gram, 50 gram, 50 gram at a speed of how much?
700 meter per second.
Okay, 700 meter per second, right?
Yes.
The maximum force, okay, speed, mass, the maximum force that can be imparted by the person holding is 200 Newton. I am just saying like that, 200 Newton. Find the number of bullets. Find the number of bullets that can be fired. Fired by the gun per minute. Can you do this? How to do this?
Can try.
It's a very important question. Real life. So what do you need to do? Find change in momentum of one bullet. Then multiply it by n. Okay? You can see, I'll tell you weight of AK-47 gun. Weight of AK-47 gun. 3.4 kg, right? Let's say 4 kg. So 4 into 10 is how much? 40. Got it? 40. Let's say 40 Newton is that one. And okay, we'll talk about recoil velocity later. Very soon we will do that. So right now you take that 200. I am approximately holding it to 200 Newton. Now say. I think I should have done this question after doing recoil velocity. Do it fast, please. First find for 1. What is the momentum of one bullet? What is the change in momentum?
So 35 Newton seconds.
So you have to do like this.
Oh, that's the impulse.
So change in momentum, let n number of bullets be fired by the gun. Okay, that is Ft is equals to, we know n, Ft is nothing but I equals to Ft is equal to nothing but n into change in momentum, delta P, right? But T is not in second, it is in what? Minute, I said. Okay, so this force I have already given to you. You need to find n. So T should be in minute. So how much is it? 1 minute is equals to 60 seconds. So 1 second must be 1 by 60. That means F by T into 60 must be equals to n into delta A P, which you can write this as n into m into what? Change in momentum. Change in momentum, right? So change in momentum, delta V, which you can write F into T by 60 is equal to n into m. Delta V would be equals to how much is it? 700 meter per second.
Yes.
700 minus 0. That's it. Solve it and tell me how much is. F I have given to you. T should be 1 second. How much is it n? Fine. T is 1 minute.
So why have you divided by 60?
We are converting 1 second into 1 minute. 1 second is how much? 1 by 60th minute, na?
Yes, sir.
Oh, you have sent the work. Let me check now.
So there are two unknown variables. One is T and one is n.
No, T is 1. The answer is per minute.
Oh, T is 1.
1 minute now we have convert.
Yes.
It is F into 1 by 60 is equal to N into mass is how much? 50 grams, 0.5 into 700.
Yes.
Now give me the answer. Okay, good.
I'm getting 0.095.
0.095.
0.95.
N, you need to find N. F is 200. 200 into 1 divided by 60.
So I'm getting
0.5 into
10.5.
700. How much?
So I'm getting something 10.5.
10 point?
10 point. So I'm getting 1 by 10.5.
How?
Oh, so wait, I did something wrong.
Where is the mistake then for us?
So if we cancel 200 by 60, it will be 10 by 3. Then,
Okay.
so then I am getting the delta mv is equal to 35.
So
Denominator is larger, it should be 0.0.
come on, 700 meter per second, na? 700 meter per second. Wait a minute. kg is how much? Is it 0.5 or 0.5? It is 0.5, na?
0.05.
It is
So
0.05.
0.05.
Yeah. 0.05. You see, actually I am teaching 12 and so many things, they had some different data and so just that's why, sorry. 0.05, it will be 0.05, so bad of me, 0.05.
So, but till the data will be same now.
No,
It is coming.
Yes.
So I did like this only, sir. I got something 0.095.
Yes, sir.
0.5 into
So the impulse I am getting is 35 Newton seconds.
yeah, so it is 700.
So then
Mass is this, cancel, so 0.05 na? 0.05. If I remove this 60, let us see per minute per second how much.
So I think the force should be more.
I
so
think
that
I have
it
done
will
one
cancel
mistake here.
the-
Na, I have done. This is 1 minute. Yeah, we have done one mistake. We have done right only. Make it is 60. Don't do it by 60. First find out in second. Okay?
so then we can multiply this
Yeah.
data by 60.
Yeah. That would be better. Na? Yeah, we did that mistake here. Actually, it should be, yeah, it is a mistake. It's ambiguity is taking place here. Sorry. So, n will become here. There is
So 5.7.
yeah, 5 points. Now that is it. N is coming as, because it is a number. So 5.7, which is approximately, let us take this as 6. Okay?
Yes.
6, or we can take, no, yeah, it's a number. So let us say 5.7, or let us 6, approximately 6. 6 bullets per second. Per second. So, minute how many? Into 60?
It is a bit contrasting.
6 into 6 is 36. Right?
Oh yes sir.
36 bullets. Or rounds. They say round. Rounds per minute. What is AK-47 speed?
So it should be more than 36, so because it should be 360 because
360. I think it's
it
360.
was
I'm just
multiplied by 16. So
round is how much? 600 rounds per minute. And how much you are getting? 60. So 6 is the 30. 360 rounds. 360 rounds per minute.
yes,
Why it is? We are almost close, but why so far? Because of this recoil velocity. I will teach you how to find the recoil velocity in the upcoming topic. Okay. One more type of question from impulse. May I clean it?
Yes,
yes,
sir.
Now, graphical based question on impulse. Look at this. I give you a graph, maybe something like this. As you can know, I have already discussed with you. Let's say something like this. This is 3. Let's say this is 1. This is 2. I don't need that. This is 2.5. This is 4. Okay? Second. Now my question is, okay, so given whatever be the object, irrelevant, is 4 meter per second initial speed. Clear? And mass equals to 2 kg. Got it?
Yes.
Calculate the impulse of the force and the final speed of the body. Calculate I and final speed. Can you? Can you? How will you do this? How will you do? May I show you how to do it?
Yes, sir.
yes,
First of all, find the area under the curve. That will give you the impulse. I'm giving you the hint. You try it. So I will be the area under the curve, right? Or you can take this as a homework also. Take this as a homework. It will take time to do. So you find the area under the curve. So you
Sir,
can
total area, no?
total area. Let me give you this quantity also. Let this be maybe 1 point. Let this take this as 2. Keep it simple. 2. So you have to find the complete area. So that gives you the impulse. This is nothing but m into delta v, right?
yes,
Mass I have given to you. To know the final speed, so v would be u plus delta v, right?
yes,
Yes.
So do it. Okay.
So can you repeat once?
You see, you will get the total area. Total area will be equal to the impulse.
Yes, sir.
Then from there you can find the change in momentum, which is nothing but this area is equal to m this delta v. So from here you can easily find delta v because mass I have given to you.
Yes, sir.
And then
So
once
at
you
the
know,
fin-
yeah,
yes. So at the final position, the time is 2.5 seconds.
2.5 second. This is 4 second.
Oh, okay, okay.
This is 4 second. Then you can easily find it, right?
Yes, sir.
Yes, sir.
So do this at you want. May I clean it?
Yes, sir.
Yes,
Now let's come to Newton's third law. I hope you know this much. What is Newton's third law?
yes, sir.
What is it?
Every action is equal.
Every action has an equal and opposite. Every action has equal and opposite reaction.
Yes,
Equal and opposite reaction. Opposite reaction. Also one thing. Action and reaction force. Action and reaction force do not act on the same body. Okay? and are opposite in direction and are equal and opposite in direction and are equal and opposite and are equal and opposite. This is also in another way I can say Newton's third law. So if you are pushing the wall, let's say you are pushing the wall, okay, so if you are pushing the wall, so you are pushing the wall with your force. Look at the body, it is in your hand. The wall is pushing you back with the same force. Look at the vector length I am giving, they are same only. This is L, this is also L. They are equal and opposite, right? They are equal and opposite, they are cancelling each other's effect, right? So remember this, that they are in the opposite work. Huh? Now some examples of Newton's third law, okay, or some problems. How do you explain this? First of all, I think I have already explained to you. There is horse and cart problem. Horse and cart problem. What is it, horse and cart problem? You'll see here. So horse and cart problem. The horse and cart problem is the application of Newton's third law, which says for every action there is an equal reaction. If A exerts a force on B, then B will also exert a force. Okay. Action reaction, the horses pushes the against the ground. Now if both of them are pushing each other, right? Both of them are pushing each other. So how come the cart moves forward, right? So this is the cart. This is the cart here. Okay. Now, if the horse is pulling it, here, okay, please excuse the diagram of the horse or whatever be it. But the horse is pulling it, right? So if this fellow is pulling this one, so this is also pulling this fellow back. So they should cancel each other. How come they are moving? The answer lies to that. The answer is that the horse has to hit the ground at an angle theta, which I have already explained to you earlier. So this is the action force, and this is the reaction force. This reaction force, you can break it into two components. One will be, so if this is theta, means which one will be theta? This would be theta, right? But we are not going to take this angle. This is theta, right? Because we always take from the normal, na? So this is theta, means then this is theta. So it is up to now which way you take. Generally we take it from the normal. So in many book you will see that they will take from the ground only, considering this theta from the ground. But actually the convention is to draw the normal, from there we take it. Okay, so doesn't matter. So if you are taking this angle, then you will see that the weight of the object. I'll do it here again with the one. So this is theta. You can break it into two components, r cos theta and r sin theta. So r sin theta, what it does, it balances the weight of the cart and the block, the overall weight, okay, and mg, not wg, mg, and r cos theta do not have any unbalanced force, so it will move forward, right? So r cos theta will be responsible for ma, means it will be responsible for acceleration. Got it? So the horse must hit the ground at certain angle theta. If you don't, then it will not move forward. I have already explained you earlier. Okay? Same case is for the walking. Same case for the walking for us also. Now another case of this is that if I on a table or any body which is at rest, if I keep any book or any object at rest on the table, so what are different forces acting? No force is acting. You will see now here is I am introducing you to free body diagram. So you see here it is mg and the reaction force is r. So r minus mg is equals to 0. So that is r equals to mg. These two forces are equal and opposite. So although I am drawing it here, remember that weight is acting on the here and the reaction is acting on the block. Okay?
Yes.
Okay now?
Yes, sir.
Yes.
Okay, then that's it for today.
Thank you.